All right. Hi, everyone. My name is Jillian Wilson.
My name is Zach Walton.
And for our project, we're making a wound dressing. And so we're going to use Chitosan as the wound dressing and Microsponges as the drug delivery system for it.
So a little background on our project. The goal of what our research is trying to do is we're trying to create a Chitosan PVA, and a Chitosan microsponge hydrogel. And the goal is to measure their rate of drug release. Why Chitosan? Chitosan is a very bioavailable polymer that occurs naturally in nature. We're using it because it's going to be naturally biocompatible with the human body. It's hydrophilic and antimicrobial. Those properties will allow it to be good for drug delivery, and especially with integration into a body system. It can also be cross-linked with other polymers to form a stronger gel. So this is where the PVA comes in. Where our goal is to cross-link the PVA with the Chitosan to make a stronger and more durable gel that will better be able to deliver our chosen drug. Speaking of drugs, it's capable of drug delivery applications alone or with microsponges. So microsponges can also deliver drugs just like hydrogels can, but our goal is to combine them and to see if the rate of drug delivery and release is better than either alone. Microsponges, as I said, they are also a type of drug delivery platform. They are very porous. They can hold the drug and release it under the right conditions. So these conditions can be stimulated, or they can be done with heat. Usually it's aimed at looking at time so that the release is done over a controlled period of time. And it is a ideally better way of drug delivery than just a hydrogel.
Okay, so a little background on hydrogels. So hydrogels are basically this 3D polymer matrix that is hydrophilic, so it can swell in water, but it's not water soluble, so it can't dissolve in water. So the Chitosan is the hydrogel that we are using, and it's a natural hydrogel. Some hydrogels can be made naturally or synthetically, like the PVA we're going to use. So natural polymers are more biocompatible and non-toxic, like collagen, which is a protein found a lot in nature. And so Chitosan is ideal for this because we want it to be biocompatible, but we also want it to be strong. So we're going to try to use a synthetic polymer like PVA to increase the mechanical strength and make it more durable.
So again, microsponges, we went over that, but in this case, we are going to be forming them by dissolving ethyl cellulose and the drug of our choice, salicylic acid, in dichloromethane. This solution was spun and it was added dropwise to 1% PVA solution to form the microsponges. Why did we choose salicylic acid? Salicylic acid has good abilities such as decreasing inflammation and speeding up the healing process in wound repair. It is also antimicrobial, which is great for infections, especially when bacterial infections are involved.
Okay, so we have the formations of the Chitosan alone and the Chitosan with PVA, but we have the microsponges alone, but we're going to put the Chitosan and microsponges together. So we had a Chitosan solution that was spun with the microsponges so that it evenly dispersed throughout the gel, and then we put it in the desiccator to get all the water out of it. So afterwards we could test the swellability and look at it under the microscope.
So these are some of the hydrogels we produced. In figure 1, this is a normal regular Chitosan hydrogel derived using acetic acid and distilled water. It contains roughly half a gram of Chitosan and about 50 milliliters of water, or DI water, with 2% acetic acid, so about 2 milliliters of acetic acid. We did use the desiccator here to dry the gel, and then using a very small amount of water, we added it back to the dry gel to get this moist and well-swelled gel that you see here. It'll also expand, take up much more area, so the surface volume of the gel itself will increase. Figure 2, this is a Chitosan PVA hydrogel. It contains roughly half a gram of Chitosan with about 2.5 grams of PVA. It was cross-linked using a freeze-thaw cycle. So in order to cross-link two polymers together, you have to have some kind of method, which could be chemical, biological, or physical. In this case, we did a physical method of freeze-thaw. So in a freeze-thaw cycle, you'd probably do it roughly 3 to 5 times over the course of, in that case, 3 to 5 days. We did ours for about a 18-hour freeze cycle and a 6-hour heat cycle. We froze it at -20 degrees Celsius and heated it at about 30 degrees Celsius. In figure 3, this is just a chitosan hydrogel that contains microsponges dispersed throughout the gel. The microsponges are the small white particles that you see. This is a dry gel. It's not hydrated or swelled. So the gels will still contain the sponges, but they will not be swelled or in suspension at this point. This was taken after the gel was dried in the desiccator, hence the dried appearance and why it does not look the same as figure 1.
Okay, along with this, we also looked at our hydrogels under the microscope. So this first batch is just the chitosan under the microscope. So the chitosan was dissolved in a 2% solution of acetic acid, since chitosan is water insoluble. And once it was dried, we added water, but the dried ones were viewed under the microscope. Actually, no, the swollen ones were. So you can see the chitosan hydrogel surface is a more porous looking surface. We're not sure exactly why it looks like that. We think there might be some air bubbles in it, and that's why it's showing that, but we're not 100% sure yet, and that's something we're looking into in the future. And also, when we zoomed in a little bit more past the surface, it shows more what we expected. You still see some little particles in there, but that's probably chitosan that didn't dissolve, even though when we looked at the solution, it looked dissolved to the naked eye, but there's still more we would have to do in the future to get it dissolved in this acetic acid solution. You can see the lines of it showing like the cross-link of a polymer.
It also may be due just to the drying nature of the gel with the interaction with the microscope. To the naked eye, some of these obscurities wouldn't be seen, but under the microscope, they can reveal a much changed surface than what you would be able to see. And to the chitosan PVA hydrogels, on the top left is a chitosan PVA gel at 700 magnification. You can see the darker streaks, which we attribute to being cross-links within the structure. This was done at a very, very close range. Any size is also not invisible, or it's not visible to the eye. Bottom left, this is a chitosan PVA gel that's been swollen a slight bit. This is just to elucidate some of those hydrophilic properties. What you see in the middle there, we attribute to an undissolved particle of chitosan or PVA. In that case, it won't affect the aspects of the gel or in delivery in that case. And if you look on the right, we have a short video of a chitosan PVA gel. If you look here, you can see some small objects slowly moving to the right. Again, this is a swollen gel, so there's been water added. And these are just particles that are slowly moving throughout the 3D polymer network within the gel. And they're benign. We attribute them just to the fact that water has been introduced.
We also looked at the microsponges of the chitosan under the microscope. So as you can see in the top left, this was the unswollen chitosan and microsponge hydrogel, and you can really see the porous structure of the microsponges there, where some places are blurred, some aren't on the microsponges. So that shows that these are in fact microsponges, which is good, which will be good when we look at the rate of drug release, which we haven't been able to do yet, but hopefully by the time of the conference we will. And also there is a picture of chitosan and microsponge gel that is swollen. So you can see it's a little hard to see, a little blurrier, so it shows that there is in fact some water there, but you can still see the very porous structure of the microsponges showing what we expected.
As an addition, all the images taken were done using a Hyrox microscope. These images are the best quality that we can provide, and we hope that they serve your purposes. Thank you for watching our video and attending our lecture. Hopefully you found this interesting, and we all hope you have a great day. Thank you.